Displacement is a vector, but it has also the credit of being first vector. It is termed as fundamental vector. Why? Because the whole idea of vector originated just to explain this very first quantity of vector type, that is displacement. Displacement vector starts from initial, goes to the final position. Just example, I have shown A to B, then B to C, then C to D, like this. In 3 parts, the journey takes place. A, B, C, and D. The final one. Displacement will be A to D. This is the nature of displacement vector. Now, what is position vector? See, I'll consider 2 axis coordinate x, y. You might have 3D or 2D. 2D I am considering the example, and say the body was here basically and it came to be in its motion. It came from A to B. Remember, when it started from A and has gone to B, its displacement would be A to B, AB vector. But then we want to describe the whole thing in terms of position vector. And what is position vector? Position vector is a vector starting from origin and going to the present position of the body. When the body was at A and origin at O, the position vector shall be OA. Say it is R1, position vector of this body. And then body came to be, the position vector now changed, it became R2. See the triangle, and if you remember triangle method of vectors, the method of addition of vectors, one can easily say here R1 plus S, that is equal to R2. You might say S equal to R2 minus R1. What is this R2 minus R1? This is the difference of the 2 vectors. Final minus initial. So you might say change in position vector. One very important result, and this is in applied physics, in applied mechanics rather, it's most commonly used. You might remember displacement is equal to the change in position vector. What is displacement vector? It is the change in position vector. Now, vector is always written in either 2 components or 3 components. Suppose for one object, you say the position vector was x1i plus y1j. For the other position, it will be x2i plus y2j. And you want to find the difference. In order to find the displacement, this will be x2 minus x1i plus y2 minus y1j. This is the displacement vector. If the 2 position vectors are given, this is the way how you find the displacement vector. Now, in order to write down its magnitude or the value, you know how to go ahead. Simply square the component, add them together. It's going to give you the magnitude of vector. If it is 3D vector, similarly you'll have one more component, k component here also. One more term will be added here. I have tried to make it clear. You see here, this thing. Then how to proceed with the graph? You must remember, when we try to draw the graph for displacement, velocity or acceleration with time, you see you are never sure regarding S, V or A. It will be given in the information in the question. But regarding T, everybody is confident that time will never decrease. So since it is common, it's not mentioned even that with the increase in time this thing is happening. Everybody knows that's nature. time will always advance, time will always proceed. So what we do in common, we always consider time along x-axis, and along y you have the option of choosing either of these three, S, V or A. One more thing, while drawing the graph, this graph is just impossible. Not only with S, V and A also cannot be over here, because this is depicting that time is constant, time has stopped. That is impossible. Time will always proceed. So this is hypothetical graph. With displacement, it is quite not possible. With velocity, we are bound to use it sometimes, but then you will keep in mind that this is going to be hypothetical in nature. Now, regarding other graphs, I will consider three cases. See, this is constant velocity. If the velocity is constant, displacement will regularly increase in a linear manner. And if the accelerated motion is there, see, this angle will regularly go on increasing. Accelerated motion means velocity is also increasing. And if it is a deaccelerated motion, that means the velocity decreasing, but the displacement is increasing. So this gives you an idea that whenever there is acceleration, ST graph shall be a parabolic graph.